look at your list of numbers that were on that paper. Why do you need to know all those? Well, because yeah, it's like you're classifying numbers. If you were taking a designer class and you were talking about materials, you'd have to be able to classify materials. Or if you were in a woodworking shop, you would have to classify different kinds of wood. Is this cherry wood, redwood, mahogany, cedar? What kind of wood are you working with? In math, we have to classify numbers. So if you don't know what a natural number is, you won't know how to answer the question. So let's start with, here is the smallest set of numbers. When you were a baby and your parents started talking to you, you were starting to recite the alphabet and the number system. What's the first number they teach you? 1. 0?
I'm sorry.
0? No, really, they do. They start with 1. I don't know any parent that says 0, 1, you know, right?
Now I'm gonna do that one.
I'm gonna do it.
Negative
-1.
Negative 1, 0, 1. I'm gonna do that with my niece. She's 2 years old. But no, we do. We start with 1. 1, 2, 3. Those are called the natural or the counting numbers. Okay. Now, when we're counting with our little babies, do we say 1, 1.5, 2?
No.
Okay. So you know that the numbers that are not listed between 1 and 2 or between 2 and 3, those are not natural counting numbers, right? Okay, so you start to get a little older and you go to kindergarten. In kindergarten, they introduce, after 1, 2, 3, they say, what about 0? What does 0 mean? Nothing. It's 0. You have 0 of whatever they're talking about. 0 candy bars. So 0 comes before the 1 on the number line, and that is now the set of whole numbers. So when we say whole numbers, you include 0. Okay? So the difference, now is 1.5 a whole number? No, it is not. So you got to know what a whole number is. Okay, so then, do you remember in probably like 2nd grade, they gave you, in math, they gave you they started doing a number line, and they said, okay, when we created the number line, how did they make it? They went like this. See if you remember. And they did this. What are these numbers? These are integers. These are integers. So what is the definition of an integer? It's the set of whole numbers and their opposites. All the opposites. So the opposite of 1 is -1, -2 is -2, and so forth. 0 does not have an opposite. Now, what they did was they said, okay, plot -2, 3, and I don't know, let's put a 1 in between here. So what did you do? You put a dot here at -2, you put a dot at 1, and you put a dot at 3. That's how we graphed the set of integers, okay? Then, we got a little older, and what did they make us do? They made us take fractions and add them, or multiply them, or we did this. Remember this? What kinds of numbers are these? These are called rational numbers. They didn't say we're going to add and subtract rational numbers. But what is a rational number? A rational number is a ratio of 2 integers. Any number that can be written as a decimal that repeats or ends, we say terminates. Terminates. If it repeats or terminates, it is a rational number. So The number 0.33333, what is that equal to? It's 1/3. If you can write a number as a fraction, and it could be negative 1/3. You can write a number as a fraction, or as a decimal that ends, or as a decimal that repeats, that is called a rational number. What if you have a decimal or a, not a fraction, but what if you have a decimal that does not repeat, does not, or does not terminate? Can you think of an example of a decimal that doesn't repeat? Square root of 2, square root of 3, square root of 5, square root of 7, square root of 11. Pi, the number e. These are non-repeating, they do not end decimals. If you were to convert this into a decimal, you would see there's no pattern. Those are irrational numbers. Those are crazy numbers. They don't repeat, they don't end. I always remember is irrational, is crazy. Like if you do something at home, and your mom or dad gets upset, let's say you go out and they tell you to be home at 11 and you come home at 1, your parents start flipping out on you and they tell you you're grounded for the rest of the year and no phones, you can't go here, you can't go there, and you say, Mom, you're being irrational. Totally irrational. Think of that as like she's being crazy. She's like out of control. So that's what these kinds of numbers are. So we have rational and irrational, and every single one of these numbers is a real number. So this is what you should have come up with in this sequence. This is a good flow chart for you to understand the differences and how these numbers are related to each other. Okay? Good? Anybody have any questions? I saw some very interesting graphs, but if you can remember this one, this is a good flow chart or diagram. Anybody have any questions? All right, we are moving along. We are going to do review, major review. All of this stuff that I cover today, it should be old hat to you. If you could pass 2 over to that side. What? That was just a worksheet.
No, I'm talking about that.
No, I'm gonna just work on these. This is not a free test now. Why are you hearing a lot of classes giving free tests?
I've gotten a lot.
You've gotten a lot?
Yeah.
You know why? We have to show growth. We want to show what you know before you learn something, and then they're going to test you after you learn, and hopefully, your scores go up with instruction, and we can compare your before and after.
She had an extra and gave it to me.
Oh, okay, then I think you have enough here. Thanks. All right, we're going to start off evaluating, or actually, we're going to start talking about modeling words with algebraic expressions. This is review. This is all review. I made a little chart for you. You have to know adding, subtracting, multiplying, and dividing. The words that correspond to these operations. If you don't know, then you're not going to be able to take a real world application and transform it to be able to solve it, because you have to write it into a math equation. So words like sum, more than, increased by, total, and added to are words that mean adding. You're adding. If you see the word difference or less than, actually less to should be written on here. You should write less. Fewer than and subtracted from. Those are subtraction. The words product and times are multiplication. And a lot of you guys were asking me what the word quotient means. It's a division, and divided by is also division. So, let's read this first problem. It says, Which algebraic expression models the word phrase 7 fewer than a number t? So your variable is t and the number is 7. You're going to put those into some kind of algebraic expression. So the word fewer means minus. But when you see than in the sentence, or in the phrase, I should say, you're going to reverse it. So in this problem, it's not 7 minus t. This one would be t minus 7. Now, I like to go over this example with you. If you see 7 less t, 7 less than t, or 7 is less than t. Are these saying the same thing?
No.
All three of them are different. You need to really watch each word. 7 less t is just simply 7 minus t. The word than means you're going to write these backwards. This would be t minus 7. The word is the less than sign. 7 less than is less than t. Those are 3 different answers. So you got to know those. I always look for the word than. If the word than is there, I reverse it. Now why, if I have, look at this question right here, number 10. It says, 4 more than a number b. More means plus. Than means I'm going to write it backwards. The right way to write this would be b plus 4. But could I write 4 plus b for this one? And the answer is yes. Well, why did I have to write these different then? You know why?
Because you can get a, you end up with a different answer when we switch it when it's a
Yep.
subtraction.
Yep. The reason also is the commutative property for addition says, do you agree that if I said, what's 3 plus 5? What's 3 plus 5?
8.
8. What's 5 plus 3?
8.
8. Can I write them backwards? Yeah. What's 1 plus 2?
3.
What's 2 plus 1?
3.
So that's okay. Well, let's do subtraction. What's 3 minus 5?
Negative 2.
Does that equal this? No. That's why it doesn't work for subtraction. This is called the commutative property for addition. And I know at some point, probably in middle school, they talked about the commutative property for addition. It means you can add in different order. You can add it in a different order. You'll get the same answer. Everybody adds differently. When I add, I like to get 10s. I like to see if I can get a 10 if I were adding a bunch of numbers. Some of you guys do that. Do you guys know what I'm talking about?
Yeah.
Okay. So you can do that with addition, but with subtraction, you got to be careful. You just have to make sure that you carry the sign with the number that's in front. Okay. Go back to this. Got it? How would you write which expression models 2 times the sum of A and B? 2 times the sum of A and B. Which one do you think it is?
H.
It's H. Good job. Okay, so you're going to do, let's actually do 11 and 12 together while we're here. Let's finish this page, make this page done. 11. We have, how do you write the product? What does the word product mean? Multiplication. The product of 8 and the sum of a number x and 3. What would you write? Anyone? The product of 8. Yes.
I put 8, and then parentheses, x plus 3.
And that's what I did too. Perfect. Good job. And number 12, the quotient. Quotient is division. The quotient of It's the difference between 5 and a number n and 2. Okay? All right, now what we're gonna do is evaluate an expression. What does evaluate mean? Evaluate it.
Explain it.
Explain it. How about solve it? You're going to solve this for certain numbers. Now, it doesn't say simplify. Simplify means make things easier. Make things easier. This is asking you to evaluate. This is an expression. Why is it an expression? It does not have an equal to sign in another expression on the other side. So, an equal to with two expressions, that's an equation. What they want you to do is evaluate this for when A is -4 and 5 is B. What are you going to do here to evaluate this expression? I know you guys know this. You're going to plug those numbers in for those particular letters. So, in other words, where you see an A, you're going to replace -4. And where you see a B, you're going to put a 5, right? So now, what other information do we expect you to already have under your belt when you do this problem? I'm not going to tell you. Can I do 5 minus 8? No. We have rules. Just like when we get in a car and we have to obey the street signs and the speed limit, we have math rules. There's rules in that problem. Yes. Order of operations. Everyone needs to know order of operations. They are adding what's in combining parentheses first. So this needs to go. What's -4 plus 4?
0.
0. So do I just cross this out and leave a 7 here? No, what does this go to, this whole thing?
0.
Goes to 0, because 0 times anything, you do multiplication next. So 0 times 7 is 0. What's 3 times 5? And what is 15 minus 8? So your answer is 7. Got it? Okay, cool. All right, see the next 4 problems? Those are yours for homework. You can do those at home. All right, the next thing we're going to talk about is taking expressions and making them simpler to understand and write and read, and we're just going to make them just easier for us. So here's an expression, 7x squared plus 3y squared plus 2y squared minus 4x squared. That's a loaded expression. Can I make it simpler? And how? What are the rules? How do you make something simpler?
Combining like terms.
You're combining like terms. What is a like term in this problem? How many terms are there in this problem?
2.
Right now, how many are there?
4.
There's 4. 1, 2, 3, 4. There's 4 terms. How do we know which ones are alike? What are we looking for?
Similar exponents and variables.
The same variable and the exponent. Okay, so I'm going to say that these two look similar, right? What if one was x squared and one was x cubed? Is that similar enough?
No.
No, they have to be spot on identical. Exactly. So now that we have identified that 7x squared and -4x squared are similar, they're alike, what do we do? How to combine them? What do you do?
You take the signs.
What, you take the what?
Sign.
What are these numbers called? What are these numbers called? I want you to know what they're called. They're coefficients. You guys got to get this terminology down. These are the coefficients. 7 is the coefficient of x squared, and this is -4, that's coefficient. So when you combine these two, what do you get? 3x squared. And I'm going to say that these two are alike, because they are. What do you get?
5x squared.
5y squared.
I mean,
Got it? Okay. What is B asking you to do?
distribute.
It's asking you to first distribute something. How do we distribute? We multiply. The first set of parentheses has a -1, so we're going to distribute, right, -3k minus m. and the second has a 2, so 2k minus 8m. So far, okay? Now, what are the like terms? And you should alphabetize them. What comes first in the alphabet, a K or an M? K. So let's group up all of our K's. What do you get? Negative K minus 9M. Try 5A and B on your own really quick. Let's see if we can all get the same answer. Check that out. Negative 3j squared plus 5j minus 7k. Do we have everyone okay on that one? Yeah?
Wait, what? It's dividing by J, isn't it?
No, that's a plus sign.
Oh.
This is right here.
Okay.
Yeah, the copy quality's not that hot, guys, sorry. These are all pluses and minuses, there's no division. Yeah, I apologize. That's a plus sign. I thought they wouldn't do that, they wouldn't put a division there. How about for B? Someone give me what to do here. I wanna hear the next line and then what you combine. Go ahead.
You distribute negative 1 to the parentheses 8a and then negative 3b.
Mm-hmm.
And you distribute positive 10 to 2 to make it 20a
Mm-hmm.
and negative 50b.
You got it, and then
you
what?
combine like terms. So you
What,
would,
what should we put first?
so you would subtract 8 from 8a from 20a, and you would end up with 12a,
Mm-hmm.
and then you would put together negative 3b and negative 50b, and you would get negative 53b.
You got it, perfect. So the next 9 problems, these are homework. These ones are homework, you can try them on your own, we'll check them tomorrow. Okay, the next thing you should have under your belt is how to solve equations. This has been something we've been doing for the last 4 years, if not longer. When you have, what's the difference between an expression and an equation? An expression does not have an equal to sign, although sometimes we evaluate them and we come up with an answer. But an equation has 2 expressions set equal to each other and we solve them. How do we solve them? Well, you have to undo each operation to get that variable by itself. Sometimes you can do them in your head, and sometimes you need to undo you have to do the inverse operation that undoes each side. Well, for this one, very easy. How do we know what x is? What number added to 4 gives us a negative 12? Well, we have to undo 4 plus 4. The inverse operation of that would be to subtract 4. And whatever you do to one side, you have to do to the other. You guys all know this very well. Your answer comes out to be negative 16. How do we check this answer? How do we know it's right? Well, if we plug this number in here and evaluate it, does negative 16 plus 4 equal negative 12? It sure does, it's right. So for homework, you're going to review these 4. These are called one-step equations. But what's a multiple step equation? Well, that involves sometimes the distributive property in bringing one term to the other side. Let's talk about this one. What would we do here?
So we would first distribute 3 to the y and then negative 1 minus 3.
Yep, so you get 3y minus 9. Okay, now, this is always interesting. We've got variables on both sides and we have numbers on both sides. What would you do to solve this?
Take the side with the smaller variable and
Yeah,
subtract it.
the smaller side variable is this one. So I'm going to get this to the other side. That's the way to go. A lot of people want to bring the number over first, and that's fine too, but you will not make as many math errors if you start with the variable and take the smaller one and bring it to the bigger one. That'll stop you from having a negative variable, and then you have to divide by a negative. So that it just helps, it's easier. Now we have to get negative 27 over here, because we've established that the variable goes on the left side. So now I'm gonna add 27 to both sides. And what do you get? 3y, bringing this down, and I'm running out of room, guys. So 3y is equal to negative 9 plus 27 is 18. And now, how do you undo 3? Yep, and you got it. That's your answer. You're gonna do, let's do this next one, number 2. Everybody, let's see how many of us can get the right answer. Try this one right here. On your own. Okay, let's hear some answers. What'd you get? -1. Anyone get something else? She is correct, -1. Everybody get -1? Okay, you can do the next 16 for homework, they're not hard. Okay, let's think about the equations that we just solved. The equations we just solved. This is a sometimes equation. It works, we can get a solution, and it works only sometimes, and that's when x is -16. This is a sometimes equation. It works only when y is equal to 6. It doesn't always work. It only works if we put y is 6 into the problem. This one is a sometimes equation. It only works when x is -1, okay? So if we can get an answer, we call those conditional. It works based on the condition that x or whatever the variable is this answer. Okay, now let's look at this one. Let's do this. Let's start it out. What do you feel like doing first? For problem 4a, what should we do? Look at the left side. I heard it, combine like terms. What are your like terms? And what do you get? Well, right here, what do you get here?
4.
You get 4, right? Now let's clean up the right side. When you add these variables, what do you get? Okay, now do you remember when we had variables on both sides? What did we say to do? If we did that, what do we get? 4 is 5. Is 4 5? Is 4 equal to 5? If 4 is 5, we're in trouble. Is 4 ever 5?
No.
Is it always 4 is always 5?
No.
Is it sometimes it's 4 5? Is it never? It's never true. This is never. This is no solution. You'll never ever be able to make 4 equal to 5. Never. There's no solution. Thanks. Okay, try the next one, B. On the left side, what do you get? 6x minus 2x is 4x plus 5. How about on the other side? Do I hear an echo? 4x plus 5? It's the same thing. We could cancel these out and say 5 equals 5. Does 5 equal 5?
Yes.
Always. It always equals that. 5 always equals 5. This is an always answer. This means that whatever number we want to put in for x, it will work. So there's infinite solutions to this equation. Infinite solutions, whereas this one, there's never, 4 is never going to equal 5. This is a no solution. I want you to try 4a and 4b down below on your own and tell me what kind of a equation is it? Is it an always, sometimes, or never equation? And what's the actual answer? Is it no solution, infinite solutions, or can you get a solution like x is 3? What'd you get for 4A?
Never.
Never. Good. And how about B?
Always.
And I agree with you guys, always. We've got,
You wrote 4x on the little, did I?
oh, thank you. 4 and 1 is 5, my bad. Always, this is an infinite solution. Okay, are we good with that? So for homework, you're gonna practice the next 4. Alrighty, now we're gonna talk about, do you guys remember what a literal equation is? A literal equation, for example, area is equal to length times width. If I wanted to carpet this room, I wanna know how much carpet to go purchase, I take the length of the room and I multiply it by the width of the room, and I tell the people I need 400 square feet of carpet to carpet this room. Well, what if I have carpet? Let's say I have 400 square feet of carpet, and I want to create a room. I just don't know how far down, what the length or the width should be. So let's say I want to mess around with this formula, and I don't want area. I don't want to go buy carpet. I have the carpet. I just want to know what the length should be of this. So what I could do is I could rearrange this formula so that instead of A being L times W, I could get W by itself by dividing both sides by L. This is what you're going to be working on right now. These are equations with more than one variable. Do you know how to mess around with an equation? And you're going to need to know this when we start graphing lines. You guys remember linear equations? How are you going to be able to write an equation? It's like a slope, intercept, y equals mx plus b formula. That's a literal, and another example of a literal equation has 2 variables. So your job is to take these equations, and here's a good one. Celsius is a unit of measurement that Europeans use, like Canadian, and if you go to Canada, they measure the temperature in Celsius. We, the Americans, measure it in Fahrenheit. So if someone said 30 degrees Fahrenheit or 30 degrees Celsius, they're not the same. So what if you want to know the conversion? Well, if you want to know what the Celsius degree is, you take the Fahrenheit temperature, you subtract 32, and you multiply that by 5/9. Well, what if I want to know what the Fahrenheit temperature is? So I'm in Canada, and they tell me what the Celsius degree is. How do I do that? How do I rewrite this equation so F is by itself? Now, this is the easiest way to do this. I'm going to rewrite it first. Okay. Before you can dig into F, you got to get this out of here. This is a problem, this 9. Get rid of 9 first. If we multiply this side by 9, multiply this side by 9, what happens? You've got 9c is equal to 5 times f minus 32. Now I have a product here. How do I get rid of this 5? Divide both, no distributing. Divide by 5. So capital F minus 32 is really 9/5 c. What did I really do? I multiplied by the reciprocal, 5/9, 9/5. That's how I got this 5/9 over here. I multiplied by 9/5. Now the last thing, how do I remove the negative 32? What are you going to do? Add 32. Add 32 here, so actually 9/5 times the Celsius temperature, if you add 32 to that, that is going to be what the Fahrenheit temperature is. I want to do a couple more of these because for this one, 33, I've heard students say they want you to solve for h. They want you to get h by itself. How many of you are going to divide both sides by a half? Don't do that. This is what, if you were to divide by a half, this is what you'd have. A over a half equals BH, and then divide by B. So you'd have A over a half. I don't know if you do, I've seen this, divide by B. I don't know. It just, it's messed up. No. Think of what is, instead of, this is a division. You know 1/2 is a division. What's the how do you change that? Multiply by 2. So get rid of the 1/2, we're gonna multiply by 2. If you multiply both sides by 2, you end up with simply 2A is BH. And now, how do you get rid of the B? Now, isn't that much easier? 2A over B is equal to H. Isn't that a lot easier? Doesn't that look nicer than whatever that is? I don't know what that is. Okay, so try 34. What would you do first? You want to get G by itself. What would you do?
You square root both sides.
Not
I
square
mean, not
root.
square root, you square both sides.
Not
I
square.
mean,
Say it louder.
Divide by 2.
Multiply each side by 2. So 2s is equal to 2g squared, or gt squared. And then get, I want g by itself. So what are you going to divide both sides by? T squared. Now, if you were solving for t, you'd have to take the square root. So g is 2s over g. I'm sorry, over t squared. My bad. Let's try this one. How do you get, this is an easy one. Volume is length times width times height. How do you get the volume by itself? Very good. And the last one, the simple interest is principal times rate times time. So simple interest is equal to over principal times time is equal to R. Easy. You can do the 3 on the bottom. Okay,
Can I see that?
which one? 36? 35 and 36. Easy?
Yeah.
Okay. Next.
Is it
Solve.
with all of this or not?
Yeah, it's not much.
Yeah,
It's
I know,
not
I'm
much.
just basically.
Yeah. Okay, now, can you translate an inequality expression into these are verbal descriptions into an inequality? For example, you guys know what the words less than, greater than, you know those symbols, right? That's all old stuff. Well, how would you, like we did in section 1.4, how would you write x is at most 25? Now, if you're not sure, think of a number line. If x, the solution, is at the very most 25,
X is less than or equal to 25.
Yep, you got it. X is less than or equal to 25. Sometimes, because a lot of people think of the word most as a greater than sign, it's not. For this one, it's a less than. How about,
If it's at most, it doesn't go over 25.
right, very good. Yep, that's how you should think of it. How about 8? X is not equal to 25. How would you write that?
X is less than.
Like that? How about 9, number 9? X is greater than 25, and X is less than 25. You guys know those, right? Okay. How would you write, now you guys take a look, review these graphs. One new thing I'm gonna throw at you in this class, when you see an open circle, in Algebra 2 and pre-calc, we're gonna start getting you used to interval notation. I want you to replace an open circle with a parenthesis. In a closed circle, you're gonna use a bracket. Can you remember that? I'll remind you, whoops, this should go this way. This would be going that way. Parenthesis, open circle, bracket, closed circle. So your graphs are gonna look a little different. We're gonna, instead of instead of using an open circle, use a parenthesis. In a closed circle, I want you to use a bracket. So we're running out of time. We'll finish this stuff, but go up to, if you can, read these inequalities and try to write them out. And see if you can recall solving these two right here, these inequalities. And we'll finish this tomorrow. Have a good day. Thank you.
Fun birthday.
Thanks.